Every critical system you run today assumes someone at the center is ultimately trusted. That works inside a single organization. But what happens when trust has to span agencies, companies, or even countries? In this module, we'll walk through how trust shifts from centralized control to distributed models and what that actually means for your architectures. Most enterprise and government systems are built on an architecture of control. At the top, a small set of root authorities, CAs and HSMs, are treated as absolutely trustworthy. Everything else inherits trust from them. Below that, identity and access management platforms act as gatekeepers. They define who exists in the system, which roles they have, and what resources they can access. At the edge are users, devices, and applications that must accept those central decisions. This pattern is efficient and familiar, but it concentrates power and creates clear single points of failure: technical, organizational, and even political. When two organizations need to collaborate, they rarely merge their identity systems. Instead, they extend trust using federation protocols like SAML or OpenID Connect. One side issues tokens, the other side agrees to accept them. Conceptually, it's like building a bridge between two separate security perimeters. It works well, but all cross-organization trust is now concentrated in that bridge and in the identity provider that operates it. For architects, that means treating the IP as critical infrastructure. If federation is compromised, every connected system is exposed. In this centralized world, trust often looks like governance by decree. A small authorized group defines the rules, runs the root certificate authorities, and signs key documents and contracts. Everyone else is expected to trust those decisions because policy, law, or contracts say so. The model is fast and orderly, but it concentrates power and creates very attractive targets. Recognizing this keys to the kingdom structure is essential context before we talk about distributing trust. When multiple organizations need to work together, trust doesn't come for free. Each side maintains its own systems, its own records, and its own version of the truth. As a result, every agreement becomes custom work. Contracts in paper or PDF, manual reconciliation of data, endless point-to-point checks, and siloed databases that never quite align. Cross-organizational trust effectively becomes its own project, expensive, slow, and fragile when you try to scale it. In most enterprise and government environments, trust is concentrated in a handful of critical components: a root CA, a central identity service, or a core database. If that root is compromised, everything built on top of it becomes suspect. Logs can be altered, evidence can disappear, and even audits often rely on the very systems they're supposed to verify. The underlying issue is meta-trust. Who verifies the verifiers, and how do we avoid a single point of catastrophic failure? As soon as you cross borders, trust stops being purely technical and becomes deeply political. Each jurisdiction brings its own laws, regulators, and red lines. GDPR in Europe, data sovereignty rules in parts of Asia, sector-specific laws in the US, and many others. That creates a jurisdictional wall. No country, agency, or major enterprise is comfortable handing ultimate control of its data or keys to someone else. Any realistic blockchain-based trust architecture has to respect those boundaries by design. Distributed trust replaces a single central authority with a network of mutually checking participants. Each organization runs its own node, but they commit to a shared ledger so everyone sees the same ordered sequence of facts. No single party can silently rewrite history because new entries only become valid when multiple independent nodes reach consensus. Cryptography then locks in those decisions. Digital signatures tie transactions to specific keys and entities, and hashes link them into an auditable chain. Together, multi-party consensus and cryptographic proof allow enterprises and governments to treat the ledger itself as a durable trust anchor. In enterprise and government settings, blockchain almost always means permissioned, not public. Participants are identified organizations, not anonymous strangers. Every node is tied to a real legal entity, with contracts, regulators, and auditors behind it. That shifts the trust model. You still get a shared, tamper-evident ledger, but you control who may join, who may validate, and how consensus works. This lets the ledger align with policy, compliance, and governance requirements instead of fighting them. Blockchain gives us a new kind of source of truth for multi-party systems. Instead of each organization keeping its own divergent history, we maintain a shared state. Every authorized party sees the same record of events. Because entries are cryptographically linked, that history is practically immutable. You can correct it going forward, but not silently rewrite it. And since every change is signed and timestamped, the ledger is inherently auditable, providing clear evidence of who did what and when. Distributed trust provides resilience, transparency, and shared verification of facts, but it comes with trade-offs. Shifting from a central database to a consortium ledger introduces coordination steps. Nodes must agree, signatures must be verified, and state must be replicated. That increases latency and limits throughput. You also take on more complexity, more software components, more organizations in the loop, and higher governance and operational overhead. Designing in this space is about choosing how much performance you're willing to trade for stronger resilience, auditability, and multi-party trust. There is no single configuration that optimizes everything. For most enterprises and governments, the destination is hybrid trust, not a clean break from existing systems. Existing PKI and IAM remain the roots of identity. CAs still issue and manage keys, credentials, and roles because those are deeply embedded in policy, contracts, and operations. What changes is where coordination and proof live. The shared ledger becomes a common evidence layer. Who approved what? In which sequence? Under which policy version? You can think of IAM as defining who is allowed, and the ledger as recording what actually happened in a tamper-evident cross-organization log that everyone can verify. When you're choosing a trust model, begin with a straightforward question. How many independent parties are involved? If it's essentially one organization with internal actors, a well-governed centralized database is often sufficient. When multiple organizations are involved, ask whether they're comfortable relying on a single, clearly identified intermediary. If they are, a traditional hub model still works and is usually cheaper and simpler. If they aren't, the next question is whether they need a neutral, verifiable audit trail across parties. When the answer is yes, that's the point where a permission-distributed ledger becomes justified. Traditional enterprise and government trust follows a fortress model. One authority controls the keys, decisions are fast, and operations can be highly efficient. But that concentration of power also concentrates risk. A single compromise, outage, or insider threat can undermine the entire system, and outsiders largely have to accept logs and reports on faith. A network model distributes both trust and failure. Consensus, shared immutable records, and resilient topologies introduce complexity, but they also add verifiability and collective control. As an architect, your role is to decide, use case by use case, how much fortress to retain and how much network to deliberately design in.